Hi, this is GCSE 9 to 1 Crammers. It's never too late to start revising, and this way you can do it anywhere. Test yourself by stopping the video after each question. Have a go at answering it and then play on to check it. Run through the questions as many times as you need until the answers pop into your head. Today we're revising physics topic 4, radioactivity and radiation, and we'll be covering alpha radiation, beta radiation, gamma radiation, medical uses, and health risks. Definitions. What does it mean if a substance is radioactive? A substance gives out radiation from the nuclei of its atom. What is radioactive decay? It is where unstable nuclei emit radiation to try and become more stable. Can you change the rate of radioactive decay? No, you can't. Radioactive substances emit ionizing radiation. What is ionizing radiation? It is atoms that knock electrons off atoms, creating positive ions. What three types of ionizing radiation are there? Alpha radiation, which emits an alpha particle from the nucleus, 2 protons and 2 neutrons. Beta radiation, which emits a beta particle, a fast-moving electron from the nucleus. And gamma radiation, which are very short wavelength electromagnetic EM waves. Put alpha, beta and gamma in order of their ionizing strength. Most ionizing is alpha radiation, then is beta, and least ionizing gamma. What two numbers must be equal on both sides of a nuclear equation? The atomic mass and the atomic number. Explain what is meant by the term radioactive decay. Unstable isotopes decaying into other elements and giving out radiation as they try to become stable. Can you make unstable nuclei decay by physical conditions, for example temperature or chemical bonding? No, you can't. What is meant by isotopes of an element? Atoms with the same number of protons but a different number of neutrons in their nucleus. What do radioactive substances emit? Ionizing radiation. What is ionizing radiation? It is radiation that knocks electrons off atoms. What does ionizing radiation create? Positive ions. What does the ionizing power of the radiation source tell us? How easily the electrons can be knocked off. Alpha decay. Alpha decay. Alpha radiation is when an alpha particle is emitted or lost from the nucleus. An alpha particle is 2 protons and 2 neutrons, so the nucleus symbol for an alpha particle has a mass number of 4 and an atomic number of 2, and a chemical symbol of He, the same as in a helium nucleus. Therefore, when it comes to balancing an alpha nuclear reaction equation, you need to remember the mass number decreases by 4. While the atomic number decreases by 2, and a new element is formed. Another way of spotting an alpha nuclear reaction is by the symbol of radiation added on the end, the Greek letter A for alpha, but they could also use the chemical symbol for an alpha particle at the end of the equation. So learn to spot both. Remember, with nuclear equations, the mass and atomic number must balance on both sides of the equation. So the mass is 234 plus 4. Do the maths, it's 238. And that balances with the reactant side. The atomic mass is 90 plus 2. Do the maths, and it's 92. And that balances as well. Properties of alpha radiation. Particles are quite big, heavy, and slow. This means they don't penetrate very far into materials, are stopped very quickly, after only travelling a few centimetres in air. They're absorbed immediately by a piece of paper and they're strongly ionizing. What is alpha radiation used for? Smoke detectors. How does alpha radiation work in smoke detectors? Ionized air particles cause a current to flow. If there is smoke in the air, it binds to the ions, reducing the number available to carry a current. The current falls and the alarm sounds. What is alpha radiation? It is when an alpha particle is emitted from the nucleus. How many neutrons and protons does an alpha particle have? 2 protons and 2 neutrons. What happens to alpha particles in the air? They only travel a few centimeters. What happens to alpha particles if they hit a piece of paper? They're absorbed. Because of their size, alpha particles are strongly ionizing. What does this mean? They bash into a lot of atoms, knocking electrons off them before they slow down, which creates a lot of ions. An unstable isotope releases a particle made up of 2 protons and 2 neutrons from its nucleus. Name this type of decay. Alpha decay. Explain why the use of ionizing radiation in the smoke detector does not pose a threat to the health of people living in the house. Alpha particles have a small range in air and will be stopped by a thin sheet of material, so the alpha radiation inside the detector cannot escape the detector. What happens when an atom decays by emitting an alpha particle? 2 protons and 2 neutrons are emitted from the nucleus. Why are alpha particles strongly ionizing? Because alpha particles are big. They bash into lots of atoms, knocking electrons off them before slowing down, which creates lots of ions. What type of radiation does alpha consist of? 2 protons and 2 neutrons. Describe the properties of alpha radiation in terms of their penetration through materials, range in air, and deflection in a magnetic field. Alpha particles are big, heavy, and slow-moving, meaning they don't penetrate very far into materials, and are stopped very quickly after only travelling a few centimetres in air. They are absorbed immediately by a piece of paper. A protactinium PA generator is used to produce a sample of radioactive material. In the first stage, uranium U decays into thorium TH. The decay can be represented by this equation. Determine the type of radiation emitted and work out the atomic number of thorium. We can see the type of radiation is alpha by the Greek letter at the end of the equation, which we know stands for the alpha nuclear symbol. He with a mass of 4 and an atomic number of 2, so the mass number decreases by 4 and the atomic number decreases by 2. So to find the atomic number of thorium, 92 minus 2, do the maths, and it's 90. Which type of radiation is absorbed by paper? Alpha radiation. Beta decay. Beta decay. When a nucleus decays by beta decay, a beta particle is formed when a neutron splits into a proton and an electron. The electron then shoots out of the nucleus at high speed, leaving the new proton behind in the nucleus. The symbol for a beta electron can either be a lowercase e or the Greek symbol B. A beta particle has virtually no mass and a relative charge of -1. So to help balance the charges on either side of an equation, a beta particle has a mass number of 0 and an atomic number of -1, and the beta symbol E. In the exam, you need to spot if an equation represents beta decay radiation. Look to see the mass number doesn't change. Next, check to see if the atomic number has increased by 1. Finally, in beta decay reactions, a new element is formed because the number of protons or atomic number has gone up, and beta radiation is emitted. Make sure if you see it written like this in an equation, you remember it is beta radiation. What are the properties of beta radiation? Beta particles are quite small and quite fast. This means beta particles can travel a few meters through the air. They can penetrate paper and penetrate fairly far into metals, but not as far as gamma rays can. For example, they can be absorbed and stopped by a sheet of aluminium around 5 mm thick. They are not immediately absorbed by the material like alpha particles are. Use of beta radiation. It is used to test the thickness of thin sheets of metal. Always remember that in nuclear equations, the mass and atomic number must balance on both sides of the equation. What type of radiation does beta consist of? A fast-moving electron from the nucleus. Describe the properties of beta radiation in terms of their penetration through materials, range in air, and deflection in a magnetic field. With beta radiation, particles are quite small and quite fast, which means they can travel a few meters through the air. They can penetrate paper and go quite far into sheets of metals, but they are not absorbed immediately by the material. Which type of radiation only penetrates through 5 mm of aluminium? Beta radiation. When the nucleus of a molybdenum-99 atom decays, it emits radiation and changes into a nucleus of technetium-99. What type of radiation is emitted by molybdenum-99 and give the reasons why? Beta radiation, because the mass number has not changed and the atomic number increases by 1. A new element is formed because a neutron has become a proton. Determine the type of radiation emitted as protactinium decays into a new element in this equation, and give a reason for your answer. Beta radiation, because the atomic number showing the number of protons has gone up by 1 and the mass number has stayed the same. Gamma decay. Gamma decay. Gamma rays are very short wavelength electromagnetic waves, which have no mass and no relative charge, so does not have an atomic number. Properties of gamma radiation: they pass straight through the air. They penetrate far into materials without being stopped, for example a thick sheet of lead, or meters of concrete. Eventually they hit something and cause damage, and they're weakly ionizing. Uses of gamma radiation: for example detecting cracks or blockages in underground pipes, or flaws in thick sheets of metal. What type of radiation does gamma consist of? Gamma has electromagnetic radiation. How is gamma radiation different to alpha and beta radiation? Gamma radiation is an electromagnetic wave, not a particle. Describe the properties of gamma radiation in terms of their penetration through materials, range in air, and deflection in a magnetic field. Gamma rays are weakly ionizing because they don't collide with other atoms. They pass through them. They pass straight through air, penetrate far into materials without being stopped, and eventually when they do hit something it is damaged. Which type of radiation can penetrate 5 centimeters of lead? Gamma radiation. What is gamma radiation used for? Gamma radiation is used to detect cracks and blockages in underground pipes, to detect flaws in thick sheets of metal, and it is used in medical tracers and emitters to detect diseases in the body. Medical uses and risks of radiation. Explain how medical tracers work. A radioactive isotope is injected or swallowed by the patient. It is tracked using an external radiation detector as it travels around the body. A computer can produce an image from the radiation detector, showing where the radiation is most concentrated. Which types of ionizing radiation sources can be used in medical tracers and why? Gamma and beta can be used in medical tracers, as they can be detected outside the body. Medical tracers are injected into a patient's body. This involves some risk to the patient's health. Explain the risk to the patient of using a radioactive substance as a medical tracer. Radiation causes ionization that may harm or kill healthy cells. How can radiation cause cancer? Lower doses of radiation can damage cells, by ionization, causing them to mutate and divide uncontrollably. How can radiation cause the cells to die? High doses of radiation can kill cells completely by damaging them so much they can't repair themselves. What is radiotherapy? Radiotherapy is the treatment of cancer using ionizing radiation, like gamma rays. What are radioactive implants? They are usually beta emitters that can be put next to or inside tumours to destroy them. What are the side effects of radiotherapy? Radiation can also damage normal cells, which makes the patient feel very ill. Even though there may be a risk, doctors frequently use radioactive substances for medical diagnosis and treatments. Suggest why. The benefit of diagnosis and treatments are greater than the risk of radiation. Both X-ray machines and CT scanners are used to produce images of the body. Before switching on the X-ray machine, the radiographer goes behind a screen. Explain why the radiographer does this. X-rays are ionizing, which can kill or damage cells. Any stray X-rays are absorbed by the screen, which reduces the radiation dose to the radiographer. The key to exam success is learning consolidation and keeping this topic fresh in your mind to nail those questions in the Physics GCSE Paper 1 exam. If you go over these enough times, you'll be able to answer any questions on this topic confidently in your exam. This is GCSE 9-1 Crammers, and if you like the content of this video, give us a thumbs up. And if you have a question or need help, give us a comment below. And don't forget, smash that subscribe button if you want more Crammers videos for your exam success. Thanks for watching and see you again soon.